Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM art students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Hi, everybody. Welcome back to our next episode of Space on Earth. I'm Taylor.
I'm Shaylee.
I'm Addie.
And I'm Wyatt.
And today we're going to be talking about sustainability in space and space exploration. So first, I kind of want to talk about why space sustainability matters in the first place, and to kind of talk about the definition of sustainable space. That's referring to our ability to carry out our exploration of space and everything that we're doing, all the missions that we're sending out, while preserving the environment on our planet and around it for the future. So that's, managing and tracking satellite operations and making sure that we're reducing and preventing space debris that can be caused from different rocket launches. And it just assures the long-term usability of all those pathways and environments that we have.
Taylor, do you want to talk a little bit more about some of the concerns we have and why we should be looking at sustainability?
Yeah, absolutely. So right now, as of 2025, there are over 8,000 active satellites in orbit, and there's so many more planned. And we can estimate that there's about 130 million pieces of space debris that are smaller than 1 centimeter, so smaller than your thumbnail, orbiting Earth. And that's excluding 3,000 or 36,000 pieces larger than 10 centimeters. And so all of that leads to this overcrowding, which means that it's difficult for us to send missions into space and get them back safely. And so without managing how are we using the space, how are we keeping track of everything that we're putting into space, it can really threaten the safety and accessibility of that area outside of our planet.
Taylor, do you want to go ahead and talk more on some of the consequences that can happen if we don't start acting on all of these different debris and other things that are around our atmosphere or around our planet?
Yeah, totally. So currently right now we have a theory, it's called Kessler syndrome, where it's a scenario where you're going to have one collision in space of space debris, and it cascades all these other collisions of everything bumping into each other. And as we're seeing, like I said before, there's a lot of debris in space for this to be happening with. And so this could potentially mean that all of that low Earth orbit area, or LEO, could be unusable for any sort of research or commerce that we're doing in space. And there's also a lot of talk of, we use space and we use the satellites for really critical technology that we use in everyday life. And all of those collisions or space traffic, it could interrupt stuff like climate observation satellites. So that's your weather system, navigation, GPS, anytime that you're driving and you need to know directions. And even large scale internet and online connections. And there's also, of course, the ethical and kind of political issues where we have seen an issue before of trying not to let space be too weaponized, of how do we keep out things like missiles and nukes from being all that we use space for. And so when we have less restrictions on how we use the space around our planet, that makes it easier for countries to send stuff into space and use that area with intent of harming other people. And so when we manage that a bit more, we have a clear picture of what we're doing and what's going on. If we're talking about sustainability moving forward, Shaylee, do you want to talk a bit about some of our recent efforts that the government's been making?
Yeah. So there has been a ton of different efforts made towards the sustainability of everything, whether it's governmental, something done in the private sector, or even just global frameworks and cooperations. And so, first off, I'm going to talk about the governmental initiatives. So there's NASA's Office of Technology, Policy, and Strategy. And so this branch helps advise the development of responsible policies to manage traffic, debris, and other emerging threats in orbit. There's also the ESA, which stands for the European Space Agency. And as of right now, there is a launch scheduled in 2026. And this mission is designed to capture and deorbit a piece of debris using robotic arms. This would mark as the first active debris removal, which is led by a public agency. And so this would make it so much easier to help get different debris out of our orbits and just make it a lot more clear, help clear up a lot of the clutter. And then we also have Federal Communications Commission and their guidelines. And so in the United States, they're making new rules which now mandate satellite operations to deorbit their satellites within 5 years of their mission completion. And so originally it was 25 years. They had a 25-year guideline, but now they're making it 5 years. And so this will help declutter a lot of this debris within our orbit.
So, Shaylee, I'm a little bit curious about the private sector contributions like SpaceX Starlink and Orbit Fab at Astroscale. Can you tell us a little bit more about that?
Yeah, so SpaceX Starlink, their satellites are engineered with an onboard propulsion and automated deorbiting software to exit orbit after decommissioning safely. And so this pretty much just means that their satellites, they have an automated system to where they have an automated system that makes it a lot easier for them to exit the orbit. And so if they have that system, it makes it a lot easier for them to take a lot more of the debris and other satellites and everything out of our orbit, just helping debris just generally. Orbit Fab, it's a startup that's building orbital refueling infrastructure, which will help allow satellites to extend their operational lifetimes. And that overall will reduce the frequency of replacements and launches. And so this will help in things just like getting the materials for every launch. We'll use less materials and we'll use a lot less materials. In Astroscale, it's a pioneering commercial company that's focused on active debris removal and satellite servicing. And so their technologies include things such as magnetic capture and rendezvous systems for cleaning defunct satellites.
Shaylee, you're talking about Astroscale just now. They already had their first mission first practice mission for debris removal. Back in February of last year, they launched their ADROS-J satellite on a Rocket Lab Electron, which with the goal of basically rendezvousing with a old Japanese upper stage that was launched like 30 years ago. And they actually succeeded. And they chased basically the upper stage in space, got really close, matched the speeds with the upper stage, and took photos of the upper stage to find the best spot to basically, I'm pretty sure it was harpooning the upper stage to then drag it back into Earth's atmosphere. I'm pretty sure that was, maybe I'm thinking of something else, but this is the first of two missions to just take down this old upper stage. And they should be launching their second satellite, which will actually deorbit the upper stage in a couple of years. I think it's probably gonna be like next year or something, but that's really cool. But now, Shirley, do you want to talk about like global frameworks and cooperation for recent efforts towards sustainability?
Yeah. Well, first off, thank you for adding that on. Wyatt, that sounds really cool. But yeah, I can go ahead and talk about the global frameworks and different cooperations that are being made. So, in the United Nations Office for Outer Space Affairs, they have developed what is called the Guidelines for the Long-Term Sustainability of Outer Space Activities. And so this basically calls for a transparency in what they're doing. It has them communicate more on traffic space coordination and debris mitigation. And so basically it's just all of the countries that work with the United Nations Office for Outer Space Affairs, they it basically has them communicate more and have them work together in a more efficient way. And so there's also the International Charter on Space and Major Disasters. This is a multinational agreement facilitating data sharing from satellites to support disaster response. It reflects principles of responsible and equitable space usage. And so just putting this in simpler terms, it is a agreement that pretty much has all of the countries share data from all of their satellites so that they can collaborate more efficiently and use it to support disaster responses.
And that kind of goes back to what I brought up earlier about weaponization of space and transparency between countries of, like you were saying, having a large group of people work together, not as separate nations, but as a group.
Yeah, thank you for that, Taylor. There is also the Committee on the Peaceful Uses of Outer Space, and they promote cooperation in the exploration and use of outer space for peaceful purposes, including sustainability measures. And so they're just making sure that everyone uses outer space for more peaceful purposes, not trying to put any harmful weapons out into space, trying to get an upper hand. They're just making sure that everyone uses space in a more peaceful and purposeful way. Wyatt, I know I talked a little bit about private sectors and different agencies, but would you like to talk about some of the different fuels, propulsion, some of the challenges, as well as rockets and stuff like that?
Sure. Yeah, I love that stuff. For fuels, we got. Well, let me start off with the basics. When you are launching a rocket, you need oxygen to burn your propellant because fire needs oxygen to, combust. But in space, you don't have oxygen. You got to take your own oxygen with you. This is why every liquid fueled rocket needs liquid oxygen with its fuel, rather that be kerosene, hydrogen, even methane. You need liquid oxygen. Let's talk more about the fuels, the actual fuels, rather than the oxidizer. We got liquid hydrogen. This is used on most rockets, like the Space Shuttle, Saturn V, a lot of rockets. It burns very clean. It is kind of hard to handle, contain. It leaks a lot. But comparing to other fuels, it's not really bad for the environment. I know some might think, oh, a rocket, it produces a lot of heat. It must be very bad for the rocket. It is very minuscule in what it does to the environment, comparable to like cars, factories, all that stuff. It's not that bad. It could be worse. We also got a kerosene, RP1, used in SpaceX's Falcon 9. It contributes to carbon emissions and black carbon release in the atmosphere. So it's very sooty, basically. And I would say the worst fuel to use hydrazine. It is highly toxic. It produces like a orange gas, and a lot of Chinese rockets use hydrazine. And there's been a lot of instances where, well, China is launching from the middle of their country ra- rather than here in the United States. We have to launch from the coasts, rather be California, Florida, Texas, so we don't drop our rocket boosters on cities. But China, there's been a lot of video evidence of just rocket boosters falling and crashing a couple miles from a city. I know I saw a picture of just like some first stage debris on like a highway. It's crazy. And it produces, like I said earlier, this toxic green stuff that it's not good for people. And it's very concerning that China doesn't have a lot of regulations in spaceflight. There's even been an instance last year where I don't remember what the company was called, but they were doing a static fire test of their first stage rocket of their first stage booster for the rocket that they are building to test if the engines are going to work. But the clamps that hold down the booster on the static fire stand weren't meant to withstand the force that the engines were going to output. So when the engines ignited, the not fully stacked rocket, just the first stage, broke through the clamps and ascended like a couple 100 meters before shutting down, and it went back and just crashed back onto the test stand. It's very concerning that China doesn't have a lot of regulations. It could be worse still. Anyways, let's get into saving money, reusing spaceflight hardware. We've been trying to do that for a while now. It basically started out with the space shuttle back in the 80s, 90s, all the way to the early 2010s. Yeah, the space shuttle was the first partially reusable rocket. The space shuttle, it's the orbiter, the part that carries the payload and crew, the external tank, which is attached to the orbiter, and attached to the external tank are the two solid rocket boosters. The solid rocket boosters would generate like 75% thrust at liftoff, and those would burn out really quick. So those would separate from the external tank, which the external tank is holding the fuel for the engines on the orbiter. The external tank doesn't have the engines. It's only holding the fuel for the three RS-25 engines on the back of the orbiter. And once the SRBs, solid rocket boosters, separate, they will fall back down to Earth and use parachutes to fall into the ocean, and then they're recovered and reflown on future space shuttle missions. And back to the actual space shuttle, the orbiter, and the external tank, those are still burning to escape Earth's gravity and try to reach orbital velocity. Those three RS-25 are still doing most of the work, but then the external tank uses up basically all of its fuel. So the RS-25s shut down. The external tank is then separated. This will burn up in the Earth's atmosphere. It's not reusable. It will be destroyed. And then the orbiter will use its OMS engines, orbital maneuvering system engines, to then give the final push into orbit. Now the space shuttle is in orbit. Then the crew do their mission, they release their payload, whatever. They can do whatever the mission requires. And then the space shuttle, with its thermal protection system, heat tiles, will do a planned controlled burn to slow down and then re-enter the Earth's atmosphere to then land back at the KSC, the Kennedy Space Center, where it launched, or I think it was Edwards Air Force Base in California, or even right here in New Mexico on STS-3, Space Shuttle Columbia landed here in White Sands because the weather was bad in Florida and California. It's really cool. So then when the space shuttle lands with, it's basically a plane. So land on a runway, and then that can be refurbished and then reflown. That was basically the first partially reusable rocket, but it was very expensive. It didn't really go to plan for how reuse is supposed to save you money, but it really didn't save NASA any money. It was very, very expensive. But then next we had the Blue Origin, their New Shepard rocket back in 2014. It is suborbital. Recently, their latest flight, I think it was New Shepard 32. The mission with the music person, I can't remember her name. Katy Perry, yeah. New Shepard, it's only suborbital. It only goes up and down. It doesn't go sideways like what you need to get to orbit. Anyways, I'm talking about reuse here. It's only one stage, the booster and the capsule, because it's only going up and down. So actually, technically, it's fully reusable, but it's not orbital. Oh, yeah, I never thought about it like that. Oh, I don't know. The first stage, it was the of New Shepard, was the first propulsively landed rocket booster in history. They beat SpaceX by a year, and that would, go up, release will use most of its fuel, detach the capsule. The capsule would go and go above the command line, and then the booster would navigate down to the landing pad, ignite its engine, and then deploy 4 landing legs, and then hit the capsule land. But yeah, they beat SpaceX by a year. Then we had, SpaceX in general. They originally wanted to try reuse with their first rocket, their Falcon 1, but that didn't really work out. They only launched 5 times. Yeah, and they wanted to use parachutes like the SRBs on the space shuttle, but they didn't really get to that. They decided to move on to their Falcon 9 rocket. 2 stages. How tall was it? I think it was like 70 meters tall. Yeah, 2 stages, partially reusable like the space shuttle, but first stage, second stage on top, payload. The first stage would launch, detach the second stage would go to orbit, deploy the payload, whatever. The first stage could do either 1 or 2 things. Flip around, ignite 3 of its 9 Merlin engines, like that's why it's called Falcon 9, and it would reset its trajectory to go back to the launch site and land on a concrete pad with its engines. What landing burn is with 1 engine, and deploy 4 landing legs to land. Or it would land on a drone ship in the ocean. SpaceX has 3 drone ships. I think they're making a 4th. I'm not sure, but that was the first really successful reusable rocket. Now, some of you might be saying, why does reuse matter? How is that saving people money? My alarm's going off. Think about it like this. Falcon 9, you build a first stage booster. Say that costs $30 million to just build the booster. You get the second stage that costs $10 million. The payload fairings, which are actually being recovered also, those parachute down into the ocean and are recovered. I think there was like $6 million. I think that's what SpaceX said. Yeah. So it's expensive, but you launch the rocket with, say, a government payload. The government's giving you $100 million, and you recover that booster. The booster you built costs $30 million. You can then refurbish it. Say refurbishing costs $5 million, and you can fly it again. So you made a profit of $65 million for just launching 1 payload and refurbishing it. So then you can launch that same booster again, make even more money from another payload, and then just do it over and over again with refurbishing. And you can make a lot of money from just launching the same hardware. Shoot, I'm losing it. And what SpaceX is also doing with their Starlink constellation, Starlink is owned by SpaceX, so they are spending their own money to build the satellites and then also launch them. So they can use a booster that they built that has made already a lot of profit. Say this booster made $250 million in profit. And the Starlink satellites that they also built costed $10 million. They can put the satellites on their own rocket and launch it And they basically launched it for free because that booster's already made a lot of profit. Now the profit is 240 million. It's basically how you cheat in space. It's very cool. And now Tex is, I'm gonna save this. We gotta go back to Blue Origin. I said earlier, Blue Origin, their new Shepard rocket, can't go to orbit. Earlier this year, in January, Blue Origin finally they launched their New Glenn rocket, which is basically just like Falcon 9 but larger. And it's just like first stage is reusable, second stage isn't. I don't think the fairings are yet, but they might be soon. On the first flight of New Glenn, the first stage was lost, but luckily that doesn't matter because their main objective was to get into orbit, and they succeeded in that. Back to SpaceX, their Starship rocket will be the first ever fully reusable rocket. The first stage will be able to come back to land and be caught by the same launch tower that it launched from. And the second stage will be able to re-enter the atmosphere with thermal protection system tiles like the space shuttle, and also be able to be caught by the launch tower. It's a fully and rapidly reusable launch system, and it's very cool. It is going to change the future of spaceflight when it is operational, and it's going to be what takes us to Mars. Yeah, that was a fun rant. Hattie Rose, do you want to talk about how space helps sustainability here on Earth?
Yes, I can. So I think the first thing that I want to mention is the climate monitoring, which first, let's talk about Earth observing satellites. So satellites like NASA's Landsat and ESA's Sentinel, they are constantly collecting data on Earth's atmosphere, oceans, and land, and that enables like carbon dioxide and greenhouse gas detection and deforestation tracking and ice sheet monitoring and ocean heat and currents, which are all very, very helpful. These insights can help inform climate policy, model future scenarios, and help design mitigation strategies for global warming, which is a really big issue. There's also agriculture optimization and food security. So, space-based remote sensing revolutionizes farming by offering data-driven approaches to boost productivity. So, there's like crop health monitoring, soil moisture analysis, yield prediction models, like NASA's program Harvest, combining satellite data with AI that estimates crop yields and predicts food shortages, was kind of cool. And then there's also pest and drought forecasting, and this can help farmers reduce fertilizer and pesticide overuse, conserve water through targeted irrigation, and avoid unnecessary tilling, which leads to reduced environmental impact, higher efficiency, and much greater food security, especially in regions that are really drought prone. Then there's also disaster management and humanitarian relief. So satellites are essential for disaster preparedness, response, and recovery. Weather satellites like GOES-16 provide images every 30 seconds, which can help track hurricane and cyclone forecasting. It sees like the intensity and the path, like where it's going to go, how bad it's going to be, that kind of stuff. Wildfire detection and flood and earthquake responses. And the satellites penetrate cloud covers and can detect ground deformation, mapping floods or earthquake zones. Recently, there was actually something that happened in Turkey and Syria, earthquakes, or Hurricane Maria, and satellite imagery actually helped responders locate survivors, assess damage, and help with direct aid. For post-disaster, satellites can support risk analysis and environmental restoration, ensuring recovery efforts align with sustainable development. There's also a lot of challenges that need to be overcome. Taylor, why should we do any of you want to talk about that as well?
Sure. So I'll talk a bit about orbital congestion. So one challenge that we're facing that we need to develop strategies for is as we're seeing more satellites launching, it becomes a lot more difficult to track where in space do we have these objects and which makes them more prone to collisions, especially like I mentioned earlier with that really small debris that's a lot more difficult to track and keep an eye on. And I also another issue is space debris proliferation. So over 900,000 objects larger than this 1 centimeter pose a risk to operational satellites. So even fragments as small as like paint chips can puncture through a spacecraft at high velocities, which puts astronauts and missions that we're sending to space in a lot of danger.
Yeah, even just looking at our own Earth, there's also a lot of environmental impacts, especially with the amount of launches that we're doing. And so I know, Wyatt, you talked a bit about the toxic propellants. And so that, along with heavy emissions, those can affect local ecosystems and affect how much toxic stuff is in our stratosphere. And so the more launches that we have, there is a much higher carbon footprint. And so if it's not addressed with cleaner technologies, all this stuff adds up over time.
That's really interesting. Yeah. Also, a challenge that I think we need to overcome, well, that will need to be overcome, is the lack of regulatory enforcement. Like I said earlier, China is kind of, I don't know, there could be a incident that results in a lot of death. And personally, here in the United States, we are doing okay, but I would be worried if something would happen in China. They don't really have a lot of regulations. Also, well, back to here in the United States and Russia, back in 1967, we got the Outer Space Treaty, which basically means share, just share space. It's for everyone, and don't bring nukes. There isn't a lot of ways to enforce that. It's not like we could really do anything about it if someone does. We just gotta yell at them. That's all we can do. Just say, no, don't do it, please. Why? Why are you doing this? There's also no centralized international authority to govern satellite traffic or collision avoidance or post-mission disposal, stuff like that.
Hi, do you want to go ahead and talk a little bit more about some of the high costs and some challenges that we need to overcome with those?
Yeah, so there's a lot of high costs when it comes to building reusable rockets, which we talked about earlier, as well as developing green fuels and performing active debris removal. This is really important to keep in mind when we're thinking about sustainability in space. There's also startups in smaller nations that are struggling to afford sustainable alternatives without international support, which is good to note. Do you guys want to add anything else to that?
I don't think so. I think we've kind of covered everything we need to cover today. Thank you, everybody, for listening and for supporting our podcast so far. As always, if there is anything that you guys want to hear us talk about, anything you're curious about, we're here to help you guys learn about anything that you might want to learn. So reach out to us, let us know, and we can do some research and do an episode on that. So thank you again. My name's Taylor,
I'm Shaylee.
I'm Hattie.
And I'm Wyatt.
and we'll see you guys next time. Bye.